Deep inside the human body sits a dynamic organ. Commonly known as the womb, the uterus is a dense, muscular structure, shaped like an upside-down pear. Looking at this diagram, we see the organ in its resting state. A typical adult uterus is compact, measuring about 7 to 8 centimeters in length. Slicing into that structure reveals a specialized inner wall called the endometrium. Driven by estrogen and progesterone, this lining physically thickens inward every month to prepare for potential pregnancy. If no pregnancy occurs, the organ executes a reset. The thickened tissue breaks down and clears out of the cavity during menstruation. Even at this resting scale, the organ is composed of layers of dense, multi-directional smooth muscle, a specialized architecture built for high-pressure output. The womb is not a passive container. It is a biological engine that exists in a perpetual state of readiness for extreme physical exertion. When pregnancy occurs, the organ transitions from a routine monthly cycle into high-demand life support mode. This wireframe model shows the infrastructure upgrade required to sustain a fetus. Notice the rapid multiplication of internal blood vessels. To accommodate a growing baby, the smooth muscle walls stretch outward to drastically increase total volume, expanding enough to hold multiples, like twins. This schematic maps out the 3 architectural zones that make this expansion possible: the dome's top section, called the fundus, the main body, and the narrow lower section, the cervix. Through this process, a compact muscle transforms into a massive, highly vascularized environment for human development. After months of growth, childbirth requires intense structural coordination to push life out. Focusing on the lower section, the cervix acts as the gateway, connecting the main uterine cavity to the vaginal canal. To allow a baby to pass, this normally tiny, rigid opening undergoes an extreme mechanical shift, dilating to 10 centimeters. While the cervix opens, the thick, smooth muscles of the fundus and body execute powerful contractions to physically drive the baby downward. By syncing extreme cervical dilation with the force of these contractions, the uterus performs enough work to rank as one of the strongest muscular organs in the body. Immediately following delivery, the tissues begin an intensive biological reset. The highly stretched muscular walls gradually pull back together, eventually settling right back at that original 7 to 8 centimeter baseline. Maintaining a structure with such rapid tissue transformations and extreme physical demands involves significant biological risks. The constant cycle of cellular growth and shedding leaves the tissue susceptible to serious medical conditions, such as fibroids, endometriosis, and cancer. The uterus is a specialized and resilient structure, defined by its capacity for extreme physical output,